Good evening, everyone. Am I audible to you all? Okay, I'm Yashvi, and currently I'm a PhD scholar at IIT Bombay. So, this course is on physico-chemical processes for wastewater treatment, and I will be the TA, or I will be taking the live sessions for you all for whatever professor has taught or whatever is conducted throughout the week, and along with some doubts if you have. So let's wait for a few minutes till like many people are joining still. After that we can start. By the time, if you want, we can have a small introduction of your background so that I can get to know what preliminary knowledge you have about the course. And yeah, so I will speak out the names. Lakshmi, can you introduce yourself along with your background?
Yes, ma'am. Good evening.
Good evening.
I'm A. Lakshmi. I'm from Khammam district.
Okay, and
I'm graduate in Vijayawada KL University, MSc Chemistry second year.
okay.
Yeah, thank you, ma'am.
Um, Krishna Kumar.
Yeah, man. Good evening. Hello. Can you hear me?
Yeah,
Hello.
yeah,
Am I
yeah,
audible?
yeah. You are audible.
I'm Krishna Kumar, PhD research scholar, Department of Chemistry, PhD Institute of Technology and Applied Research, Neelambur, ma'am.
Okay.
Coimbatore.
Chris. I guess he is not here. Goni Pudi.
Yeah, I'm there. Chris, I'm present.
Okay. Can you tell me your background?
Okay, so I'm currently pursuing my bachelor's in chemistry from St. Xavier's College, Mumbai, and I've completed my 12th and 10th from Mumbai itself, and I'm currently residing in Mumbai.
So I see many of you are from chemistry background. So, uh, what do you expect from this course, or what sort of uh, expectations do you have while joining the course?
Uh,
Like, is what is your motive to join this course? So from that only we will start the course, I guess. Yes, anyone of you can tell me uh, what's the motive of you joining this course? And how will it be useful for your field, like because every one of you will be from different background and different fields you will be working on, so just a brief on how it will be useful to you all. Okay, let me ask someone who has um Yes, Priyanshu.
Yes, ma'am.
Yeah, so can you tell me what learning outcomes do you expect from this course, and how will it help in your field? Like,
Very good, ma'am.
no, no, like, for example, some of you are from MSc chemistry and some of you are pursuing PhD. So, depending on that, how this course will be helpful to you, to your field. So, what learning are you expecting from this course? Yes, Krishna Kumar, you were saying something.
Pardon? Hello?
Yeah.
Ma'am, I'm I'm doing PhD. So my PhD work is under the material characterization and along with polymer. So it can helpful for water research. So I will choose that topic, ma'am.
Okay, so further you want to extend your research into water, uh, like broadly water treatment or maybe some water purification where this might be helpful. Correct. So this course, okay, now let's start. I guess everyone would have joined. So this course is basically about the treatment technologies that are used. Few are conventional or few are newer technologies. So all such technologies which are used for wastewater treatment, these will be discussed. So firstly in this course, let me share my screen. We will be starting off with why do we need wastewater treatment and why do we need to study that, right? Can you see my screen? So there is a general question to you all. Which of this glass, like glass A and B, glass A you see is very crystal clear water. Glass B is obviously, uh, it seems to have some impurities in it. So which one will you drink? Can anyone tell me?
Glass A, ma'am.
But are you sure that even if it is transparent, it does not have anything in it?
No, ma'am.
Yeah, so that's the point, right? By visualizing water just by saying that it is transparent, obviously the second one is aesthetically not pleasing. So obviously we know that it's harmful, but even if it is crystal clear, we are not sure that it's pure and it does not have any harmful component, because even if there are some soluble salts which are harmful to us, we need to look into it and we need to look into options how we can make the water safer, right? So that's where with increasing industrialization, what we have seen is uh, not only transparent but this sort of very uh, you know contaminated water which is visually also not aesthetically pleasing. You will definitely not consume such water. Okay, so environmental crisis due to industrialization, they are increasing day by day. And can you if you take the example, then large scale contamination of water you see here, you see all the water bodies, if industries they are not able to treat water properly, then all the water bodies they get contaminated further from domestic and household usage, from commercial usage, everything is being dumped. Like the norms are not so stringent that the things are dumped in water bodies. Further, it hello, is anyone is speaking? Can you mute yourself? Okay, so we have different types of pollutions because of the industrialization. Now, if we talk about India, then there is a constant growing population, and that is where industrialization, like more and more industries are being developed to meet the requirements and meet the demands of all such population. Further, there is much more luxurious demands of the population growing, which requires more and more industries, and at the end it emits, you see here, a lot of gaseous pollutant or gas stream in atmosphere. A lot of wastewater streams are also being dumped, which causes large scale contamination of water and air. Apart from this, now to set up these industries we need to cut down forest, also to for people to stay, you need forests to be cut so that they have areas to live. So deforestation. Now again, deforestation, you see it indirectly increases pollution, because if you see forests, they are an important they play an important role in maintaining the balance of the environment. For example, these forests, they take up the carbon dioxide and they again release back oxygen. So that's how they purify air. But here, if we do deforestation, then again the pollution is not getting under control and it stays there. Then you see increase in urban slums, which I already talked about. Then there is a lot of generation of solid waste from industries also, because these industries, they generate a lot of waste in the form of three phases. It can be gaseous stream, which is emitted in atmosphere. It can be water stream, or it can be some solid substance, which is waste and it needs to be dumped into landfill sites. And there could be water scarcity because of this, because more and more water is being used in industries and less amount of pure and potable water is drinking potable water is available. So water scarcity, water not available, right? So drinking water scarcity also can happen. uh, Further, groundwater depletion, global warming, greenhouse effects are all side effects of industrialization. Is it clear so far?
Yes, ma'am.
Okay, so these are all the crises which are prevailing due to industrialization. But in this course, we are majorly concerned about water pollutants which are present in water bodies, and all sorts of industrial contamination which results into water contamination. And how do we treat, like what will be its drawbacks and how do we treat them, right? So all this, like this course is majorly revolving around treatment technologies for wastewater. Now why from industries the pollution arise? Okay, so you are saying that air pollution occurs, water pollution occurs, there are a lot of byproducts occurring. But other than that, what are the possible reason that there is pollutants coming from industries into final water bodies or any sort of thing? So what could be the reason behind it? For example, you have already set up, uh, for example, there is a reaction, right, which gives you a byproduct, and that is hazardous in nature. Now this is a liquid aqueous stream. For example, this aqueous stream contains hazardous chemical. For example, it is a pharmaceutical industry, So it can have drugs or some pharmaceutical intermediates in the aqua stream, right? So let's say it has some drug or organic compound in water stream, right? So now this drug and organic or the organic compound which is present along with water, now we have a treatment method which removes this drug or which degrades this drug or the organic which is present. But in case if we have an instrument or if we are using an equipment which, for example, to treat this water which contains organic, you are using this reactor where you get uh, drug degradation takes place, right? So in that case, what happens? You are treating the water. But what if this entire equipment is not functioning properly? So it is outdated and its efficiency is degraded. Like this happens in your home also, right? You have RO purifiers, so it has some lifetime, and if you do not take proper care, it will go bad or it will not treat your water properly, right? So this happens everywhere. So small scale industries which have lesser amount of funds, they think of cost cutting. So outdated equipments, poor management of such instruments and technologies, so inefficient technologies, development of unplanned industrial conglomeration, and also the poor implementation of pollution control laws. All such sort of things, they are the primary cause of pollution because of the industries, right? So now once the pollution occurs, it can enter into the environment through any means, okay? It can be dumped into the water bodies, and at the end it can end up to you also, which can be hazardous for you all, right? So what sort of hazards or what sort of problems do you see if you drink polluted water? Can anyone tell me about this? What disease or what sort of toxicity it can spread if you are drinking polluted water? Anyone?
Leads to certain diseases like cholera, diarrhea, ma'am.
Yeah, so these diseases, they are because of the biological like pathogens if they are present. Have you heard that water can even be carcinogenic? Like for example, it can cause cancer to you. It can cause anemia. It can damage your organs as well. Have you heard of that?
Yes, ma'am.
Yeah, so if we talk about this, then the diseases or the toxicity that water can spread is endless, and the amount of toxicity is very major, right? So even it can cause that death to human beings and all the other living organisms, right? So this is where it is very important for us to have a proper clean water to drink, not only for us, every living organisms in the environment, may it be the ones aquatic animals, may it be living on land, and human beings or plants, everything is interconnected. Can you term that thing that if you are, for example, if fish has consumed some toxic component, it can spread or it can pass on to other forms of living organisms. So there is a terminology which you would have.
Eutrophication, ma'am.
Sorry?
Eutrophication.
No, no, no. Eutrophication is the excessive growth of plants or algae in water bodies that results into the death of aquatic animals. I'm saying
Okay,
that
ma'am.
you would have heard of food chain, right? So
Yes,
in
ma'am.
environment, everything is interconnected. So environment is, it includes everything, including water, air, land, and all the interrelationships, right? And whatever is, we are living on environment, and we are interconnected with all the parts of ecosystem. So we are interconnected, humans are interconnected with aquatic bodies, aquatic living organisms, and uh, land organisms, animals, right? So we are connected, interconnected through food chain. So once the pollution enters in any of these body, then it will transfer to another form, and higher the tropical level, more will be the impact of that pollutant. And many of the pollutants, they are so deteriorating that it will accumulate, and they will not degrade. So it will add on accumulating, and it's enhance, uh, if it will enhance the adverse impacts, right? So it is very important for us to have a proper treatment technology, or proper removal strategy, so that we can have, at the end, we are taking, consuming pure things, and we are living in a healthy surrounding, right? So for that, government has made several agencies, and also they have made certain rules, such that these rules will help in maintaining you know proper treatment. For example, there is an industry, and it has to discharge water into the water bodies, then government will make rules, so that it will be able to discharge only this much amount of water. So that all we will talk about in this slide. So these agencies, they make laws such that environment is being protected, forests are being protected, and whatever we are consuming, our health is being secure. We are having good quality of water, good quality of food, and surrounding is also healthy for us to drink, stay, sorry. So in that case, Central Pollution Control Board and State Pollution Control Board, these two are the major uh, bodies which, they are the deciding factors of various standards which apply to industries. Now, do you know that even if there is, if I want to set up an industry or even a small manufacturing plant, then I need government approval. I need approval from the pollution control boards, that I will not be discharging above a certain limit, and also my whatever norms that I am following, that are green norms, and it will not damage, or it will not cause harm to the environment, right? So you would all be aware that these set of rules are there. For example, industries you will never see near residential area, because more it is near to the people where they are staying, more it will be dangerous, right? So industries are always in isolated places. Further, there are, if you talk about small scale industries, then there is a cluster, or there are n number of small scale industries at a particular place, which is even far from residential area, right? So these all measures are, uh, government has made, so that the pollution which is spreading because of it has minimal impact on the living human beings and other living organisms which are living in that society, or which are living nearby, right? So all, there are various bodies which you can look into the lectures, which uh, adheres to all such things, right? Now there are, if we talk about water specific laws, then there are water Prevention and Control of Pollution Act, which according to which law it tries to prevent and control the pollution by making various standards. And also uh, there is one cess act, which means that cess means tax. Okay, so tax will be laid upon the industries for using water for whatever the amount of waste they are generating. Not only they should generate it below the discharge limits, but it should be within the like norms. And also if it is above that, so these bodies like CPCB, SPCB, they look into all, like they monitor the discharge which is coming out from industries, and if it is not followed, uh, they give fine to the industries also. Now we will look into the general discharge standards. So there are different types of standards which are given by all, like under these laws and by different bodies. There are different types of standards which are made for different pollutants. Can anyone name different pollutants which are usually found in water? It can be wastewater, or it can be drinking water. What could be the probable pollutants? Yes, anyone?
Some suspended solids.
Yeah, suspended solids, correct. Anything else? There are n number of pollutants which are present.
Organic and inorganic pollutants, ma'am.
Yeah, very right. So let me show you one website where you will get all these sort of standards. Okay, so have you heard of CPCB website? Yeah. Yeah, I assume that you have heard of CPCB at least, right? It's a Central Pollution Control Board, which it governs all sort of pollution. It is a sort of body which governs, makes laws, which monitors the pollution, which monitors that the industries are following norms. It makes laws for pollution control, right? So according to CPCB, which is a body set by central government, so there are various standards for discharge, right? So there are firstly general discharge standards. You look here, general standards for discharge. Now these standards are applicable for all the industries and for all the pollutants, right? So you will get all sort of data for these standards, and even if you want to look into the standards, then you will get in under this website. So there is a tab called standards, where there is water quality standard. Yeah, and also, so in this water quality standards, you will, sorry, you will have drinking water standards, and what sort of uh, uh, you will get to see here what should be the pH value, what should be the color, odor, turbidity. We will look into each of these pollutants also, how they are important and what sort of uh, toxicity it can spread. But you, for just for knowledge, this is the parameters that you need to see for your drinking water. And it should, like the maximum limit, they are given over here, that for safe drinking water, you see iron, if we talk about, then it should be below 0.3 ppm, right? So similarly, all sort of even nutrients, pollutants, everything they are given. Now there are these are general parameters. Now there are a few parameters which can be result into toxicity, right? So very toxic, for example, cadmium. Then there could be some pesticides. There could be lead, mercury, right? So um, all sort of parameters they are listed over here, and uh, you know since they are very toxic, see, there is no relaxation given to you, right? So it has to be, or like it must be below this acceptable limit. Yeah, so this is about drinking water. Now depending on the end use of water, it can be different. For example, you want to use for bathing, you want to use in industry, or you want to use for drinking water drinking purpose. Then depending on the end use, there can be some different standards, right? So now there are effluent or emission standards which are uh, general for all the industries, and also specific for different types of industries. Now um, industry could be sugar industry, petroleum industry, then there could be mining industry, then there could be battery industry, right? So if you just go inside any of the link industry wise, then you will see the list of all the, like in Hindi, in English, everything, all the probable pollutants which are coming out of the effluents of sugar industry. You will see the list of the pollutant parameters, right? So for example, the way effluent that comes out from sugar industry, its pH should be within the range of 5.5 to 8.5. Then TSS, if you are disposing on land, then it should be 100 ppm, or if you are disposing on surface water, as I said, the end use also matters. So depending on that, the permissible limit could be different, right? Then for example, you have other things also. These are nothing but pollutant concentrations. Now there are also standards. For example, the maximum amount of wastewater that could be generated from an industry, it should not be more than 200 liters per ton of sugarcane which is crushed, right? So even the amount of wastewater generated, that has been restricted by the government, so that more and more, controlled discharge and controlled pollution is taking place. Now that is nothing but you know wastewater generation standards. Now further, there could be load based standards. For example, you have BOD coming out in your effluent. So BOD, how much amount of BOD, for example, how much kgs or tons of BODs is maximum generated from any industries per ton of product formed or per ton of raw material used, that is also prescribed, so that the maximum pollutant which is generated from uh, the industry, that is also restricted. Are you able to follow this? Yes.
Yes, ma'am.
Okay, you can stop me where you want more clarification or where you are not so clear, right? So you can stop me in between. Okay, so let's move forward then. Uh, Next is minimal national standards for industries. Okay, so minimal national standards are, like, it means that all these standards are must have to be followed by all the industries, and above that there is no relaxation given to any industry about these national standards, right? So every industry has to have has to follow all these norms very strictly. right? So this is nothing but minimal national standards which every industries has to strictly follow. Now, as a citizen and as a uh, like a worker, we like, or as an entrepreneur, if I'm operating that industry, it is my duty to follow to the norms. And again, it is government duties to monitor that all sort of laws and everything is completely and well followed or not, right? And industry is complying to all sort of cleanliness in the industry or in the unit. And even the instruments are having well maintenance so that it does not create leakage or it does not create any uh, uh, you know uh, uh, some accident inside the industry, right? So all sort of monitoring also needs to be done, inspection needs to be done. That is where audits are performed, where government or some government bodies, they appoint some individuals which perform the audit of industries. Now this audit can be for inspection of all the instruments and everything, whether the performance is up to the mark, whether cleanliness is maintained, whether workers are treated properly, whether there is any leakage, whether color coding in the industries are made or not. Do you know about color coding in the industries they follow? Like, do you know? Do you have some idea of it? Can anyone tell me sort of what is that? Yes, anyone? Okay, so I am giving you 2 minutes to 2 to 3 minutes to look into what I have asked. You can search for it about the color coding in industries and how why it is important, and you can let me know. I will just be back in 2 minutes, right? Yes, could anyone find out? Okay, so I'm giving you this task to do. You can search for it and uh, come up with it in the next class. So it's basically for uh, you know there are number of instruments, reactors, n number of pipelines. So for easier identification, each one of it is color coded and it is well uh, displayed and well uh, noted everywhere that this color means this, so that it is easier for anyone to uh, identify. For example, if leakage happens or if any accident happens, it is easier to track, right? So in that case, it's helpful. You can look into more, and you can uh, tell me if you have more doubts in the next class. Yeah, someone has raised his hand. Okay, okay, let's move forward. Now there is one tool also which is known as Environmental Impact Assessment, EIA. So if we talk about this, then it is a tool which monitors or which assesses the environmental compatibility and what sort of, like, it not only does the present inspection and present assessment, but it also gives you future uh, perspective of the projects, like what could be the probable damage environment can have, what could be the probable pollution it can give, so that how much it is environmentally sustainable and environment friendly the project is, the industry is, you can find out, so that you can like this is very much required to get the government clearance for setting up your industry, for setting up your plant, etc. Right, now let's move forward. So water quality monitoring, as I mentioned, water quality monitoring is important so that we can get to know what quality of water we are having, may it be industry, may it be for drinking water purpose, or may it be for any application. It has to meet certain standards, it has to meet uh, proper uh, you know uh, the check of quality. Yes, can you mute yourself? For example, if water has too many salts in it, right? So what happens if we use such water in industry? Now industry has many reactors, many n number of pipelines. Now these salts, they have some solubility limit, right, in water. What happens, there are certain times which where conditions of temperature, pressure, they everything change in the reactors, right? So there are chances that these salts, they precipitate, they can form scaling, right? So this is one of the most simplest example why at every step we need to monitor what is the parameters of water at every step, right? So it will not only help in identifying future, present, but it will also help us in predicting what could be the future problems if we have similar uh, parameters, or if we have some pollution, or if we have some deteriorated quality of water. Not toxic, but it is not suitable for that application, right? So all such monitoring is required. Now for that we need to have the samples of water to be collected, right? And that sample needs to be checked for all sort of parameters which are there, for all sort of pollutants, and all sort of uh, you know uh, composition which are important. So now water parameters can be divided into three types. It can be physical, it can be chemical, or it can be biological. Can somebody define what are these physical, chemical, and biological uh, parameters? Yes, anyone? How do you define physical parameters or chemical parameters, or uh, biological parameters? Buddy?
Physical parameters are helpful to
Voice is
measure
breaking.
the quality of the water.
Voice is breaking. Can you write down in the chat box? You can please write down in the chat box. Your voice was breaking, it was not clear.
Physical parameters are helpful to measure the quality of water.
Sorry, physical parameters are harmful to.
Useful to measure the quality of water.
Acha, useful to measure the quality of water. Yeah, so any of these parameters, they help in measuring the quality of water, right? That you are right. Yeah, somebody has written that physical parameters are color, odor, taste. Yeah, so anything you can sense, you can feel it, right? So you can have some physical, aesthetical appearance also. You can, by touching, by feeling it, by seeing it, you can identify that there is some uh, quality difference, right? For example, if there is some color present in water, you will be able to see that this color difference is there, I should not drink the water, right? Now if the temperature, water is very cold, like temperature, so you will be able to feel it by touching, right? So you can sense that it is cold, it is warm, right? Now if uh, it has some odor, right? So you will be able to smell it. So all sort of things like parameters, they come under physical, where you are able to sense it by some your natural sensations, right? So you have mentioned like in the chat box, color, taste, odor, temperature, they are physical, but conductivity is not a physical parameter, I guess. Right, conductivity should not come in this because that is because of the salts which are present, right? So that is not correct. Apart from that, everything is correct. So I hope I have given the answer for what are physical parameters. Yeah. Then turbidity also. Then there could be some chemicals present, like for example salts, for example some organics, right? For example in agriculture, for farming, and in agriculture they use pesticides, they use insecticides to keep uh, the pests away, and also to protect the plants they have grown, right? So pesticides, insecticides, they are nothing but chemicals, right? So they are, if they come in contact with water, they will be obviously dissolved and they will pollute water. So all sorts of chemicals, they come under chemical parameters. And next is biological parameters, which are nothing but any sort of microorganism or living thing which are related to microorganisms. They are biological parameters. Now to collect sample of water, and you need to do the measurement of all these parameters, then depending on the type of parameter you need to have different sort of uh, requirement for that collection tank also. For example, if you want to measure just the physical parameters, then the bucket should be cleaned, right? Okay, so there for example, if your bucket is also only colored and there has it has some contamination, then you will not be able to uh, uh, do the proper measurement of the parameter, for example color, right? Then chemical parameters. For this you need to have a glass bottle which is cleaned, and then you need to collect the water. And at the end, for biological parameters, now biological parameters, they are nothing but microorganisms. So in this case you need to wash the container with acid, or you can use permanganate solution, and then you need to sterilize. Now why do you use acid for cleaning? Because it kills, or it acid, it can even penetrate through your skin. It is that strong, it can dissolve your skin. So what acid does, it uh, you know it degrades or it digests all sort of things which are like pollutants and other contamination is present apart from biological parameters. So anything external you will not encounter, right? And then you need to sterilize it. So sterilization is the word which is used for decontamination. For example, there are already microbes present, so they will be killed by using UV light. Okay, so UV light kills pathogens, or you can have high temperature and high pressure. Under that condition also, you need those pathogens will be killed. So this is how you collect the water. Now in case you are collecting from a tap, then you need to allow some amount of 1 to 2 liters of water to pass, so that there is a continuous flow. And whatever inside the pipeline you are, there could be some fluctuation because of that pipeline also in the parameters, so that will be avoided, right? If you are collecting from a surface water body, then in that case you need to collect it from some depth, so that the parameters which might have altered because of the stagnancy of water, that is eliminated, right? So that sort of uh, you know, precautions you need to take care. Now, what are different types of pollutants which are present in water, or what are different parameters? So, first, let's see a few of the examples. Suspended solids, then you have biodegradable organics. So, organics are nothing but it has the formula CXHYOZ. It can have nitrogen, sulfur, etc. But this is the basic formula. Now, if it can be degraded, uh, like for example, microorganisms can act upon it and it will decay, right? For example, if you have a peel of fruit which you have thrown in dustbin, so what you will see, after certain days it will degrade or wo sad jata hai, right? So that sadna is nothing but microorganisms acting upon it, so that the complex C6HYOZ, it can convert into, for example, CaHbOc, which is somewhat simpler molecule, right? For example, you can convert sucrose into glucose. That is also conversion from complex to simple, right? And at the end, what you will have? CO2, or you can have methane, depending on the conditions which are prevailing. That we will look into next classes, right? So, anything which is degradable by microorganisms, they come under biodegradable organics. Then you have pathogens which can cause disease. Now, this could be bacteria, this could be fungi, this could be viruses, right? So, viruses, we all know how deadly they can be. We all have gone through the coronavirus pandemic, right? So it can be transmitted through water, it can be transmitted through air, right? So all sort of pathogens, they can cause disease. Then there could be nutrients, nitrogen, phosphorus, which can cause eutrophication. Then there could be some toxic heavy metals which can cause cancer, which can cause damage to organs. Then there can be uh, some priority pollutants which can cause cancer, which can uh, be mutagenic, which means it can damage your DNA, right? Or it can mutate your DNA, and it can further, for example, if there are pregnant ladies, in that case it can even damage, or it can be toxic to the fetus, such that it can, the baby which is born, it can also have some uh, disability, right? So all sort of hazards we can observe because of the pollutants which are present, right? Let's move forward. We will start with looking into each of these parameters one by one. So, okay, so somebody mentioned conductivity in the uh, chat box, but there are two ways of it. So, conductivity is because of the salts. So if you are talking about salts, then it is a chemical parameter. But in case if you are talking about dissolved solids, then it will be a physical parameter. So there are interchangeable terms which you will use, right? So let's start with the physical parameters. First is the temperature. Uh, can anyone brief me, like it has already been discussed in the class, like taught by professor, how is temperature important for water? Yes, can you tell me how is temperature important? What video or PDF do you want? Soumyajit? Okay, so let me tell you. Temperature affects, right? The density, the viscosity, the vapor pressure, also the solubility of solids, gas in water. They all are dependent on water. So one of the important parameter or one of the important gases which are whose solubility is dependent on temperature is oxygen, right? Now if the temperature now for gases, if temperature increases, the solubility decreases, right? Let me give you an example. Everyone has seen uh, these aerated drinks, right? For example, Coca-Cola. So if why it is maintained at low temperature, ठंडा जितना होगा, CO2, like it is carbonated drinks, right? So it will have more amount of gas in it dissolved. Otherwise, if it is at room or if it comes near room temperature, the gas will start coming out of it and it will no more be in the soluble form. It will be evaporated or it will be vaporized. So here we are more concerned about O2, which is soluble in water. Now this O2 which is soluble in water is known as dissolved oxygen, right? And for healthy water it should be around 8 milligrams of O2 which is dissolved in 1 liter of water. So this should be the concentration, so that this oxygen will be inhaled or it will be taken up by the living organisms, the aquatic animals which are residing in the water bodies. Now, if the temperature goes high, then this dissolved oxygen will be reduced and it will adversely impact the lives of aquatic animals, right? Obviously, because even if we are not provided with proper oxygen, we will not be able to live. Similarly, these aquatic bodies, if the dissolved oxygen is altered because of the variation in temperature, they will not be able to live properly or they might die, right? So uh, that is where temperature plays an important role. Next is the specific conductivity of water. Now this is because of the presence of dissolved solid salts which are there in water. Now this could be calcium salt, magnesium salt, sodium salt. So why it is called conductivity? Because these are nothing but they are conducting metals, right? So they are mobile ions which are present in water. So they conduct electricity. So in that manner it is defined as conductivity of water, right? So these salts, since they are mobile, that is the measure which is taken into account to measure the conductivity. Now this is the indirect measure of the amount of the salts which are present. Now if you want to actually find out the TDS, which is total dissolved salts, you just need to multiply by 0.65, which is the factor by conductivity, to find out the total dissolved salts in ppm. Now ppm is a unit which is milligrams of that salt per liter of water. Now can you tell me the unit of conductivity? How, in what unit do we measure it? Okay, so it is measured in micro, like this is Siemens per centimeter. Now this is equivalent to micro mole per centimeter. Now this is the inverse of uh, omega, which is the unit for resistance, right? So since we are dealing with conductivity, it is inverse of resistance, which is mho, right? Micromole per centimeter. Then next is color, which is present in water. So color could be because of the presence of organics in colloidal suspension form. It could be because of the minerals. It could be because of the microbes, etc. Right? And these color, it can even react and form carcinogenic compounds, which are adverse, like which are harmful in nature, right? So it can be removed by adsorption, coagulation, flocculation, etc. So now if we talk about color, then it could be because of suspended and dissolved components. Now, so if we are taking into account both of it, then it is the apparent color. And if you are removing the suspended material, then and considering only dissolved components, then it is the true color. So can you tell me, how do we remove the suspended particles or the suspended components from water? Yes, anyone? How do we remove the suspended particles or components from water?
By filtration.
Yeah, right. So for that, we need to filter the water, which will have suspended components on the filter paper, or and the dissolved components, they will remain in the water phase. Right. Now next is if there could be number of colors, which, like, there can be variety of colors which water can have because of different composition. Now if you have, for example, yellow color which is present, then there is a standard platinum cobalt scale. Here you see the scale. So this yellow color matches with this, and here you dissolve this 1 milligram of platinum cobalt in 1 liter of water, so that you prepare a standard that is equals to 1 unit, right? And then you measure the color of your uh, sample, right, with this scale, so that you can actually find out uh, what is the uh, intensity of color in your sample. Also, you can measure the color. For example, if you know that this is the compound which is present, for example, any dye, say for example, methyl orange, right? This is a dye. Now you know that it has this particular color. Now in that case, you can use UV visible spectrophotometer to measure the color intensity or the dye intensity which is present in your water sample. So for that, what you need to do, first you need to make the calibration plot, because the instrument will not know, right? So here what you are doing, you are depending on the compound which is present, if you incident UV or visible light, it will absorb a certain amount of light depending on the compound, and it will emit rest of it. And also the amount of light which is absorbed, it depends on the concentration of the particular pollutant which is present, right? So in that case, you first prepare a calibration plot of known concentration, for example 0, 1, 2, 5, 7, 10, and you measure the absorbance, right? So this absorbance is nothing but the amount of light absorbed which you will get from the instrument, right? So you will have some values, and there you can plot, you will have a straight line, right? And you will get y equals to mx plus c sort of equation, where y is absorbance and x is concentration of the pollutant, right? Now initially what you are doing, you are, for each concentration you are measuring y. So firstly for x you measure y, and now for your unknown sample where you don't know the concentration, you put it in the UV visible spectrophotometer, you measure this y, and you know this equation. So by knowing y, you will be able to know the concentration. Okay, so you measure absorbance and you will get the concentration of your pollutant which is colored. I hope it is clear so far.
Yeah, ma'am.
Yeah.
Yes, ma'am.
Okay, so someone had written that sedimentation can be used for removing suspended particles. Yeah, so that can also be used. But the efficiency might vary for sedimentation, because if you have larger suspended particles, then sedimentation obviously can be used. For smaller ones, you need to have filters, okay, because it will still remain uh, in the suspension. The next set of physical parameters that we encounter is turbidity. Now turbidity is, here you see an image where you see different samples of water. Now from this left to right, the turbidity increases, which means that there is some suspension of particle. There are colloidal particles which are not allowing the light to pass through, light to pass from water, right? Otherwise, if the water is transparent, it will allow the light to pass through it. It will transmit the light, right? So these particles, what it does, when the light comes to this, it will scatter the light, okay, in all the directions. Otherwise, the light will pass through the water sample. So in that case, more the amount of solid suspended with particles, more will be the turbidity of water, right? And this turbidity is measured in terms of nephelometric turbidity units. So nephlo means cloudiness of water, so it is a unit which is used for measuring turbidity. So for that, there is a compound which you dissolve in water, and I guess it's formazine, and you calibrate the system, and then you measure the turbidity. So this is how you see the visual appearance changes as the NTU or the turbidity increases. Next is taste and odor of water. So taste and odor can come because of the dead or living organisms, some dissolved gases, minerals, right? So yeah. So for that, if you want to measure how much amount of odor is present, there is one threshold order number unit. So it is nothing but you keep on diluting your sample such that now you are not having any order. Okay, so that is the threshold. Further, if you will dilute, you will have no order, and any sample which is having any more concentration, it will be uh, not like it will have some order. Is somebody written it? Right, so that was about order and taste. Now let's move to chemical parameters. So one of the important parameter in terms of chemical parameters is pH. Now pH is nothing but minus log to the base 10 hydrogen ion concentration or H3O plus ion concentration, right? So this square braces, they define that it is the concentration or the actual activity of that hydrogen ion. Now this activity is how much mobility they have, that is also taken into account, right? So this uh, pH of solution, it can be dependent on the type of dissolved salts, it can be dependent on their nature, and also the some of the gases if they are dissolved. So let me give you an example. If you are dissolving lead nitrate salt in distilled water, right? So distilled water has usually the pH around 7, right? Around 7 it has the pH. Now if you dissolve this in water, what happens? It will dissociate mainly naturally into this state, right? Pb2 plus NO3 minus. Now this NO3 minus is one of the component of strong acid, which is nitric acid, HNO3. So this is acidic in nature. So whatever the pH of the resultant solution or water after dissolving lead nitrate will be lower than 7. Okay, that is because of the acidic nature of the salt or the ions. Now depending on the pH also, if you are dissolving any salt and for example there are metals which are present, then their ionic form also depends on the pH of solution or pH of water, right? For example, if it is Al3 plus, then at lower pH it stays in the Al3 plus, but as the pH increases, more OH minus are available, right, after some pH. So as the OH minus increases, it starts forming complex with the metals, and hence after some pH it starts forming, for example, Al3 plus. So let's say one OH comes and forms complex, so it will become 2 plus. So 3 plus, like 1 minus, will be cancelled. So it will go on increasing the complex, like the number of OH will be increasing. At some point it can even precipitate, and after some point it will turn minus. For example, OH is 4. So all that species distribution also, it depends on the pH, because number of OH are available to form complex, right? So that is why the activity of these ions also, it depends on the pH, and that is where, for example, if you want to have some removal treatment technology where you want to have Al3 plus only. Now this Al3 plus will only take into account for the removal. Otherwise, if any of these are present, they will not be effective, right? So in that case, it is better to monitor the pH. Otherwise, it can be different ionic species and the removal might not be that much efficient. Now there can be some solids which can be in the form of suspended and dissolved solids, and this could be because of inorganic salts in or organics which are present. Now if inorganics are present, then inorganics then do not degrade at high temperature, or they do not melt. So what we do, we take the temperatures about 1000 degrees. So whatever the organics will be present, they will be degraded or they will be vaporized, and whatever the remaining mass is there, that is because of the organics. And for that is because of the inorganics. While if you want to find the organic component, so total solid, you take the weight minus the inorganics, that will give you the organic solid amount. Now the suspended solids, they can also be divided into two types. One is volatile and another is inert, right? So volatile is nothing but it can be degraded by microbes. So for that, mainly the organics, you take the temperature of the solid in an oven above 500 or 550 degrees Celsius. So these suspended solids which are degraded or lost at this temperature, they are nothing but volatile, and inerts are nothing but sand, some stone, etc. Then, as I mentioned, that there are a number of ions which are present in water, including calcium, magnesium, sodium, potassium, um, strontium, etc. There are n number of lists. These are cations, and if I talk about anions, then it can be nitrate, sulfate, chloride, etc. Phosphate, right? So now you would have heard that for a balance, Na will always be present with, like for example, it will be NaCl or Na2SO4. Okay, so there will always be a balance between in the salt formation. So for depending on the valency, right, and depending on the overall composition. Now these ions cannot, you know, uh, like cations are more and anions are less, that cannot be there. So you need to have ion balance, and for that what you can do, this balance should be the percentage error should be less than 5%. So in that case you can say that the water ions are stable. So for that you need to sum all the cations in milli equivalents per liter. Now, can you tell me how do you calculate milli equivalents per liter? And what is the need of calculation in milli equivalents per liter? Yes, anyone? Okay, so let me tell you. Uh, Milli equivalents per liter is for different ions have different valency. So to account for that valency, we convert we divide the weight by by the valency, right? So in that case, what you will have is irrespective of the valency that is there. So in that case, the valency will be taken care of. So this is the formula which you will use for ion balance. So you can solve a numerical and see how it works. Now these ions, if they are present, then calcium, out of these, calcium and magnesium, they are found to cause the hardness, right? Because these ions, if they are found, they, what they does, they precipitate with the soap, and they or they cause scaling on the pipes, and at the end they will they will reduce the efficacy. So in that case, these hardness is very harmful in nature, and it can be divided into two types. One is carbonate or temporary hardness, another is non-carbonate or permanent hardness. Now carbonate hardness is because of the this bicarbonates or carbonates of the calcium and magnesium, and non-carbonate is because of the sulfate or chlorides of calcium and magnesium, right? So all these ions, they result into hardness of water. Now this hardness of water, also there is some guideline. For example, it is divided into soft water, moderately hard, very hard, right? So for different application, for example, if you want to use for drinking purpose, the hardness, I guess it is the prescribed limit is 75 ppm of calcium carbonate. So the hardness is always measured in calcium carbonate, in terms of calcium carbonate, because its molecular weight is 100, right? So it's always easier to convert it from one form to another because it's 100. So it is taken as reference compound. Now let's talk about another ion which is present, which is sodium. And as we know that sodium ions, like 97% of earth is covered with water, and oceans, they, it has salt, NaCl in it. So this sodium is one of the most abundant element present in water, but it has some negative impact on soil structure. For example, if calcium and magnesium are present, it helps in maintaining the permeability of water by keeping the soil porous, right? So now if high amount of sodium is present, it will make the soil structure unstable, and the porosity, like the porosity of the soil or the permeability of soil to pass water, it will reduce. Okay, so there is a factor which needs to be measured, which is sodium absorption ratio, which gives you the amount of sodium which is present out of all the calcium magnesium present, right? So for irrigation or agricultural application, this ratio should be less than 3, and in that case you can say that it is suitable for irrigation. Now there are another uh, you know uh, factors that you can look into is sodium percentage, which should be less than 60, which is nothing but sodium concentration divided by the concentration of all the ions. Now here you need to take care that all the concentrations are in milli equivalent per liter, so that you are not you are eliminating the factor of valency, right? And if the you know carbonates are high in concentration, what it can do is the calcium and magnesium, they will precipitate to form calcium carbonate or magnesium carbonate, and the residual sodium will increase, and which in turn it can cause infiltration in or higher sodium concentration. So in that case, residual sodium carbonate is also an important factor which is measured by this formula. Okay, so what you are doing is you are subtracting the calcium and magnesium concentration out of carbonate and bicarbonate, which suggests that whatever the residual carbonate is present, it will be with sodium, right? So that is how you are using this formula. Now another factors that you look into is sulfate, which is present. Now this sulfur, it comes from the rocks and seawater. You would have heard that there are sulfur rocks also. So from that, if it comes in contact with water, it can form sulfate, right? Now, this sulfate can result into corrosion to the building materials. Also, it can form scale formation. And if the oxygen is limited in the particular region, then it can even form H2S. Now, this H2S is a toxic gas, and it is not advisable for anyone to inhale this, right? So such you know it impacts of sulfate, for example corrosion, scale formation, and H2S formation can result because of sulfate. Now iron and manganese present in water. So you see this red or brown water, it is because of the iron rich water which is flowing, right? So again there was a news recently only that there was a red waterfall observed. Now that was because of the high amounts of iron which is present in water. right? So what it does, it can again cause scaling on the pipeline. It can corrode because iron, what it does, it forms rust, right? So corrosion in the pipeline, that all can happen. Next is nitrogen, which can be present in the form of nitrites, nitrates, ammonia, right? So nitrites, it signify that the oxidation of organics is partial because it has not completely oxidized, nitrites, and it is not the final form, so which signifies partial oxidation, and that is not at all acceptable. So nitrates, they are still uh, allowable, which is up to 45 ppm, and above that it can cause disease, okay, if it is present in above that concentration. Now nitrogen, if it is present in concentrations above certain limit, what it can does is it can cause eutrophication in water. Okay, so it will, like, it is a nutrient which is required for plants to grow, right? So more and more plants in the form of algae will grow in water. It will form a layer of algae above the water surface, and it will hamper the like it will take up like it will limit the amount of sunlight which penetrates inside the surface of water, which is required for uh, the aquatic bodies, right? So in that case, it even imbalances the dissolved oxygen concentration, and that is how it cause like it is very harmful for this aquatic animals. So firstly, it does not allow the sunlight to pass through the water, and which causes health hazard for this aquatic animals, and also it imbalances the dissolved oxygen concentration, and which is further a drawback of high contents of nitrogen. Now next is, we will start, if you don't like, do you have any doubt so far? Otherwise we will start the sample assignment, which might help you in solving the assignment, like weekly assignment which you might be given. So do you have any doubt so far?
No, ma'am.
Okay, so let's look into the assignment. This might help you in your weekly assignment. So if the pH of water is less than 7, then the water is said to be dash: basic, acidic, neutral, soft water.
Acidic.
Yeah, acidic. So the condition is pH less than 7 means acidic, equal to 7 is neutral, and pH greater than 7 is basic, right? And soft water is related to the hardness, right? So correct answer here is acidic. Next question is BOD stands for dash.
Biological oxygen demand.
Yeah, correct. Uh, for now, you can remember the full form. We will look into what does it mean in the next classes, where we will look into how do we degrade the organics and how BOD is measured, right? Next is in household, which technique is generally used for purification of water for drinking purpose. So it is RO, which is reverse osmosis. Yeah. So you all have RO filters nowadays in your home. These chemical oxidation, biological oxidation, ion exchange, they are industrial processes which are used for treatment at industrial scale. Even RO is used, but generally in water for household purposes, it is RO used out of all these. Next is, which of the following parameters is not for water quality? pH, COD, TDS, and PM 2.5, which is particulate matter.
Particulate matter.
Yeah, correct. So
Particulate
particulate matter
matters.
Particulate matter.
is the particulates which are present in air having size 2.5 micron, right? So these are nothing but pollutant, which is for air pollution. Next is which heavy metal is responsible to pollute groundwater. So it's Hg.
Mercury.
Curie.
Yeah, mercury.
Mercury.
Yeah, correct. Next is environment includes water, air, and land, and the dash which exists among and between water, air, and land, human beings, other living creatures, plants, microorganisms, and property. So it's interrelationship, right? So it's interrelationship between all.
Yes, ma'am.
The Environment
Interrelationship.
Protection, yeah, Environment Protection Act came into force in which year? I guess it's 1986. Yeah.
Yes.
Your voice is breaking. Okay, let's move to next question then. In which year a National Council of Environment Planning and Coordination was set up at the Department of Science and Technology? 1972. Platinum cobalt scale for color determination was developed by Dash. These are all very theoretical questions. In future, you will have few numericals and few theoretical questions. These all you need to remember because
Alan
you might.
Hazen.
Sorry. Yeah, option A, Alan Hazen, because it was discovered by this scientist. Next is UV visible spectrophotometer is based upon the principle of Dash.
Beer-Lambert's law.
Beer-Lambert's law.
Yeah, Beer-Lambert's law. So can you state the Beer-Lambert's law? Yes, Sanima. What is Beer-Lambert's law, and that is used in UV spectrophotometer, like that principle? Okay, so it states that the amount of light which any compound can absorb, it depends on the path length which the light travels. Okay, because in that path length the compound might be present. Okay, so on the path length which the light is traveling, and also the amount of, like, the concentration of the compound which is present, right? So the path length and the concentration is the factor which decides the absorbance, which is the statement for Beer-Lambert's law. I hope it is clear.
Yes, ma'am.
Okay. Then let's move forward. Hardness is usually expressed in dash. So the correct answer for this is calcium carbonate per liter of water, right?
Milligrams of calcium carbonate per liter of water.
Yeah. Next
Milligram
question.
of calcium carbonate per liter of water.
Yeah, very right. Next is the specific conductivity of water in micromole per centimeter at 25 degrees centigrade is multiplied by a coefficient, generally by dash. Like this is a thumb rule which you need to remember, which is 0.65. Can you give me a moment? I will just come back in a minute, right? Sorry to interrupt. Yeah, sorry for the disturbance. Let's move to the next question. The total amount of dissolved solids present in water can be estimated by measuring the specific conductivity of water. True or false? So it's the correct statement because the dissolved oxygen is indirectly related to the conductivity, right? So true. For determining hardness, the water is titrated against EDTA salt solution using dash as indicator.
Chrome,
Erichrome black tea.
Erichrome black tea indicator.
Yeah, so you are right. Can you tell me why do we choose, like on what basis do we choose the indicator for any titration? The answer is correct, but do you know the reason behind this? Okay, so I will tell you. So here, you know, the indicator that we use, for example, phenolphthalein, methyl orange, they all depend on the type of reaction that we are performing. It can be acid-base reaction titration, or it can be oxidation, reduction, redox titration. So in that case, depending on the reaction, we choose the indicator. Here we have what sort of a reaction? For example, if we have calcium ions which are present in water, then in the presence of EDTA, this EDTA is a complex which has lot of structures, for example COOH and similar structures, right? I uh, like it's ethylene diamine tetraacetic acid. Okay, so it has this 4 tetraacetic acid. Now this is a strong chelating, or it can form ligand bonds with calcium, so it can strongly attract calcium ions to form ligand bonds. Now this eriochrome black tea is an indicator like which weakly first binds with calcium to form complex, but if we add EDTA, then calcium will move to EDTA only. So in that case, there will be a color change of erio, ericlo, sorry, eriochrome black tea from wine red in the presence of calcium to blue when the calcium is attached to EDTA. Is it clear what I told? So it is because of the complex reaction which is taking place here. Yeah, is it clear? Okay, so I assume it's
Yeah,
clear.
ma'am.
Okay. And the
Yes, ma'am.
last question, it's MINAS stands for dash. So it's minimal national standards, right?
Minimum national discharge standard.
Hmm. Is it minimal national standards or discharge standards? Can anyone confirm? I am confused then. Wait, I will check. It's minimal national standards only, not discharge. Okay? It's minimal national standards. Okay, so that was the last question, and that's it from my side today. If you guys have any doubt in any of these topics, you can let me know. Otherwise, I will end this class. Also, the slides of what I had covered today, the sample assignment and the theory, that everything will be, the slides will be uploaded and the link will be shared to you. Also, the video lecture will be uploaded on my YouTube channel and that link also will be shared to you all. So you can again go through that in case if you want. And if you don't have any doubt further, I will end this class and we will meet in the next class Tuesday 7 p.m. again.
Name?
Yeah,
Your YouTube channel name, ma'am?
sorry.
Hello?
हाँ बोलिए.
Madam, your YouTube channel name?
Oh, okay. YouTube channel. See, I have included the YouTube channel name here, and again you will get the video link only. Directly, you will get the video link in a day or two, so that you can go through.
Okay.
You can still note down from here. Sorry, I couldn't. I should did check this. Oh, sorry, I have stopped the screen sharing, right?
Yes, ma'am. Yes, ma'am.
Oh, wait a minute. I will just show you. Sorry, it went out of my mind. Yeah, you can note it down from here. Yeah. So that's it from my side. Should we end the class today? Okay, so I'm ending this class for today. We will meet next Tuesday, 7 p.m. Thank you everyone for joining.
Thank you, ma'am.
Thank you, ma'am.